Hello, everyone. Like Seamus said, I'm Laurie Voss, Head of Developer Relations at LlamaIndex. And in a former life, I co-founded NPM Inc. So some of you may know me from when I used to talk incessantly about JavaScript. Now talk incessantly about AI, but the common thread is that I talk incessantly. Um, we're not going to have too many slides today before we dive in. But what I'm going to talk about today is what is LlamaIndex and why you should use it. Then we're going to dive into our workshop notebook, and I'll be walking you through building things step by step. We're going to start with building an agent. We'll build tools for our agent to use. We'll talk about how we maintain state, how we stream input and output, and how you get a human in the loop for feedback. Then we'll expand that to a multi-agent system. And then finally, we'll talk about workflows, which are the lower level building blocks that you use in LlamaIndex to extend and customize multi-agent systems. Using those workflows, we're going to create another multi-agent system that goes a little bit further than the one we created the first time, involving looping, branching, and self-reflection. And don't worry if you don't know what all of those words mean, because I'm going to explain. So what is LlamaIndex? It is a bunch of things, starting with the most obvious. We are a framework in both Python and TypeScript that helps you build generative AI applications. Today, we're going to be working in Python. But our frameworks aren't all that we do at LlamaIndex. Another thing we do is Llama Parse, which is a service that will parse complicated documents in any format into a form that can be understood by an LLM. This is critical for a lot of Gen AI applications. You have a large amount of data in like PDFs, Word documents, PowerPoint files, stuff like that. And translating that into a form that the LLMs can make sense of is a really tricky task. Llama Parse is free to use for up to 1,000 pages a day, and it will demonstrably improve what your app can do. We also have Llama Cloud, which is our enterprise service. If what you want to do is stuff documents in one end and run retrieval augmented generation on the other end without having to think about the stuff in the middle, then this is the service for you. It is a turnkey service for enterprises who have a lot of data that they want to run Gen AI apps on. Unlike the rest of LlamaIndex, which is free, Llama Cloud costs money. It is available as a SaaS at cloud.llamaindex.ai, or you can get it deployed to your own private cloud. And the final thing that I want to mention is there's Llama Hub, which is our registry of helper software. If you need to connect to any database in the world to get your data, we've got that. We want to get your data out of Notion or Slack or Salesforce, no problem. If you need to store your data in a vector store, we support all of them. If you want to use OpenAI or Mistral or Anthropic or some other LLM, we support over 30 different LLMs, including local ones using Ollama to support stuff like Llama 3 from Meta. And if you want to build an agent, and you're going to be learning how to build agents today, and you want some pre-built agent tools, we have dozens of agent tools already built for you to use. But a big question, an obvious question is, why should you use LlamaIndex? And the answer is because we will help you go faster. You are developers, you have limited time, and you have actual business and technology problems to solve. So don't get stuck figuring out the basics. We've solved a bunch of the foundational problems for you, so you can focus on the novel and interesting parts of your application. You can skip the boilerplate, you can avoid early pitfalls, you get best practices for free, and you can go from prototype to production. So with that done, let's switch to our notebook and see what we've got. Cool. So let's dive into this. What we're going to be doing today is we're going to be building first a simple agent and then a multi-agent workflow. A workflow is a specific construct in LlamaIndex. It is the building block for putting together a multi-agent system. And to get you up and running quickly, we have built a pre-built agent workflow. We've got a pre-built workflow called AgentWorkflow. What AgentWorkflow does is it makes it very easy to put together a multi-agent system. So we'll see how to use AgentWorkflow to get started. And then later on in this same workshop, we are going to drop down to the workflows themselves and see how to build one from scratch. The first step in using LlamaIndex is obviously to install LlamaIndex. While that is running, let's talk about getting an LLM. If you're going to do an AI application, obviously you need access to an LLM. So in this notebook, we're going to be using OpenAI. Like I said, we support more than 30 different LLM providers, so it's totally possible to build this using Anthropic or Llama 3 or something locally hosted, but we're going to be using OpenAI in this demonstration. To do that, I need an OpenAI API key, which I have stashed in my notebook. And now we're going to instantiate our LLM, which is a single one-liner. We just tell it what model to use and what API key to use. One of the core features of an agent, sort of the defining feature of an agent, is that unlike traditional programming where you define very explicitly your logic and what steps to take and your inputs and outputs, agents are semi-autonomous. You give them a set of tools and you give them a goal, and they will use the tools that you've given them to try and achieve that goal. So for that to work, we have to give our agent some tools. The tool that we're going to be giving it today is a tool that searches the web. It's called Tavily, and you can get a free API key for Tavily. What it is it's like a very smart search engine that is designed to be used by LLMs. So instead of just giving a list of links, it tends to give an answer to the LLM. So let's instantiate Tavily's API key, which I have got earlier. And now we will create the tool that will let our agents use Tavily. Tools in LlamaIndex are just regular Python functions. You just, you give it, you give your function a name, you give it some parameters, you execute some code, and you return a result. And the agent will figure out how to use this tool. How it does that is it uses the metadata that you've made available. One of the most important bits of metadata that you can give it is the name of the function itself. It's going to use that. You can also put a doc string at the top of your function that says what this tool is good for. This is, the agent is actually going to read this string and use this to figure out what it does. And the other thing that you can do is you can give type annotations to your parameters and your return types. So in this case, our search web method has a query, which is a string, and it returns a string. That information is going to be used by the agent to figure out how it can call this tool. So now we've created a tool, we can create our agent workflow that uses this tool. Agent workflow has a special helper method for creating a single agent, which is what we're going to start with, from a set of tools. So we're going to use that. So we bring in the agent workflow, and we call from tools our functions, and we pass an array of tools. In this case, we've just got the one tool, and it will turn this function into a tool. We pass it the LLM that we created earlier, and we give it a system prompt. In this case, a very simple system prompt that just says, you're an assistant that answers questions. And if you don't know the answer, you can search the web for information. Now that our agent is created, we can run it. Running it is very simple. You just call workflow.run. Agent workflows expect an initial message called user message. In this case, we're going to say, what is the weather in San Francisco? Oops, I forgot to run this bit. So, oops, I forgot to run this bit too. There we go. Run that bit. Now this bit works. And now this bit will work. What is the weather in San Francisco? It has to think for a bit as it asks the LLM asks the tool, and then the tool comes back. But there we go. It is 9 degrees Celsius in San Francisco right now, which is a little chilly for San Francisco. Not my favorite. So that's it. You've created a single agent. But a single agent by itself is not that useful. Let's add some more features. By default, agent workflow is stateless between runs. So it means every time you run the workflow, it's going to treat it like an entirely new interaction with the agent. that is not ideal. You'd like it to have context. You would like it to have history of what you've asked it previously so it can get smarter as you go. And to do that, we have a construct called context. So to maintain state between runs, we're going to create a new context and then pass it in. So you'll see us doing that here. What we're doing here is we're creating a context called CTX, and we are passing the workflow that we created earlier, that single agent workflow, to context. This allows it to configure the context so that it will work with this workflow. Now we call workflow.run, and we change this bit. We have added the context to the run. In this case, I'm calling the context and I'm saying that my name is Laurie. It acknowledges that. But now, if we run the workflow again with the same context, it's going to have memory of what happened before. So it remembers that my name is Laurie because it has that context. The context is just an object in memory. So you can serialize it. So you don't just have to keep things in memory for the run of your Python script. You can save them to disk. The way that you do that is you use one of two serializers, either the JSON serializer or the JSON pickle serializer. And that's what we're doing here. We are saving our context to a dictionary, which we could then store to disk. And this is us getting it back out again. We are restoring a context from a dictionary and running it again. So you can see that it still knows my name is Laurie, even though we have stored this thing to a dictionary and brought it back. Now let's talk about streaming. One of the things about workflows, one of the things about agents rather, is that they can take a while to run. The LLM has to make a bunch of calls, it has to do a bunch of thinking, a bunch of events have to happen. So you want, as a user experience of your agent, your user to know that something is happening. You don't just want them to click a button and then wait 30 seconds. So a really great way to do that is to be able to stream events back to them so that they can see stuff is going on, sort of give them an insight into the internals of the agent. So this stuff is built into AgentWorkflow. When you run a workflow, by default, you get a handler back, and that handler will stream events to you. There are a whole bunch of types of events that it will pass back to you. One is the agent stream, which will give you the stream of text back from the agent. One is the agent input, which will tell you what the agent was called to do, the agent output, what it returned, and you can get details on the tools that it's called and the results it got from those tools as well. In this case, I've commented out all of the types of events that we get from the handler, apart from agent stream. Agent stream passes a delta. The delta is like the latest chunk of text that it's received from the LLM. And what I'm going to try to do now is show you what streaming looks like in practice by running this agent again with streaming involved. If it's working, instead of just appearing in one single block, these results will appear in a stream. But sometimes it goes so quickly that it looks like it's just a single block anyway. Let's see. Oh, there we go. You can see it appearing in chunks. That's each of these deltas arriving. The weather in Saskatoon, it turns out, is terrible. Saskatoon is where one of my fellow engineers lives, and every time I run this notebook, I'm like, oh, how are you alive? But now we've got streaming working. We can do other types of events. Let's get insight into how this agent is working by running the handler with some more events being filtered out of the stream. We're going to look at agent input, agent output, and tool call result. So here you're seeing in the agent input what we passed to the agent. So you can see the system prompt and stuff like that. You can see the agent was called. It made a tool selection. The tool selection was searching the web. it decided that the tool that was called as the search web tool, this is the query that it gave to the search tool. This is the output that it got from the search tool. And then it gave some more input saying, basically, I've figured out the answer. And then you see the agent output here. This is not necessarily stuff you would show to the user, but you could show filtered versions of these to the user as a way of indicating that something is happening under the hood while work is progressing. A thing that you'll often want to do with tools is have them access your state. AgentWorkflow has a magical context variable called state that gets passed to every agent that it runs. So you can rely on the information that is in state being available to all of your agents without explicitly having to pass it in. So let's see how that works. What we're going to do here is we're going to create a new function called setName. And the change that we've made here is that it has a parameter called context. If you set context as the first parameter to your tool, then AgentWorkflow will automatically pass in the context. What we do in the tool is we simply access the state, set a variable into the state, a name, and then print out that that was done. So now we're going to create a new agent using AgentWorkflow like before. Instead of the web search, we're going to give it this tool, the setName tool, and we're going to give it an even simpler system prompt, which is, you are a helpful assistant that can set a name and an initial state where the name isn't set yet. Just like before, we initialize a context, we run the workflow and tell it that my name is Laurie, and then we will try and access the state variable and see whether the tool has set the value to my name. Ta-da! This is obviously the simplest possible use of a context variable, but you could use this to have multiple tools that pass your state back and forth and give your agent a full sense of what's going on in the world. A very useful feature of agents is that you can get what is called human in the loop. You can get a human involved in helping the agent make decisions, especially if those decisions are important. The way workflows work, and AgentWorkflow is just an instance of a workflow, is by running a series of steps which emit and receive events. You can visualize that series of steps and events using a built-in visualizer that comes with LlamaIndex that we're going to see later. Here is a visualization of how AgentWorkflow works. AgentWorkflow has an initial run step. It emits an agent input event, which runs to setup agent, which emits an agent setup event, and so on and so forth, with loops and branching and stuff like that. The key thing to get here is that if you look at these event names, they look familiar. Agent input, agent output, tool call result, tool call, agent setup. These were the same events that we were streaming earlier. That's what we were streaming back to ourselves. So to get a human in the loop, what you do with this cycle is you emit an event that isn't received by any other step in the workflow. And then you tell your tool to wait until it receives a specific reply event from the human. We have built-in event types called input required event and human response event to use for this purpose. They, by default, capture strings. But if you want to capture different forms of human input, you can subclass them to match your needs. So let's get a human in the loop. In this method, we're creating a tool. In this workflow, we're creating a tool that performs a hypothetical dangerous task. So just like every tool, we define the tool name, we define the tool docstring, we set the context, and we use this method we haven't seen before called write event to stream. This is how events get back to the user. When we were seeing those agent input and agent output events earlier, that was what was happening under the hood. It was AgentWorkflow was writing events to the stream. In this case, we set a prefix, which is just a question. and we set a username, and we'll see why that's important right now. We then call wait for event. This is the complement to the input required event. This halts the workflow until it receives a human response event. And the human response event can have requirements. Specifically, we're going to make sure that the username matches the username of the event that was outgoing. So this, you can see how in a multi-user context that would make sense. You want to make sure that the human input that you're getting is the human that you were originally asking. We then act on that input. If they say yes, we complete the dangerous task, and if they say no, we don't. And this is us creating the workflow. Again, we're using from tools or functions. We're passing in the dangerous task tool, and we're saying that you are a helpful assistant that can perform dangerous tasks. So that sets us up. Let's actually run it now. Our user message is, I want to proceed with the dangerous task. And what we're going to do is we are going to capture the events that come in from the stream. In this case, we are expecting an input required event. When we see one, we will call input, keyboard input. And once we've captured it, we will send that response back using the send event method on the context that sends the response and the username that it's expecting. So we run it. It pops open a box asking for some inputs. We say yes, hit enter, and it completes the dangerous task. So now we've got a human in the loop. So you could imagine doing anything. Like if your agent has searched the web and it thinks it's found the answer, you can get the human to confirm that you've searched the web and found the right thing. If it's doing some work, you can get it to confirm before you do an irreversible action. So now we are done with a single agent. We've shown all of the things that you can do. You can use tools, you can get input and output, you can get human in the loop. Let's talk about a multi-agent system. In this multi-agent system, the task we're going to perform is writing a report on a given topic. The way that we're going to do this, there's lots of ways that we could do this, is we're going to have 3 agents. We're going to have a research agent that searches the web for information on that topic. We're going to have a write agent, which actually writes the report based on the research that it got. And we're going to have a review agent that will look at the written report and provide feedback to the other 2. To do this, we're going to use 4 tools. By now, you've got used to the syntax for defining tools. This is a search web function, exactly the same as the one that we were using earlier. And we have 3 new ones. One is record notes, which is going to access the state via the context and save the research that the research agent has made. We've got the write report, which is going to save the written report to the state as well. And we've got the review report, which is going to read the review in the state and provide the review to the state. With our tools defined, which I'm doing right now, I'm going to actually run this agent. Oh, sorry. First, I have to create the agents because we've created the tools. AgentWorkflow comes with some built-in agent types. There's a function calling agent and there's a React agent. The function calling agent is more capable, so we're going to be using that because OpenAI supports it. Not every LLM supports a function calling agent, so in that case, you might need to use a React agent. But here we are defining our 3 agents. The way that you do this is you call function agent with a bunch of parameters. One is you give the agent a name. This has to be a unique name because remember, the LLM uses this metadata to decide what it's doing. So it's going to decide what the research agent is based on this metadata. So we give it a name and a description, and we give it a system prompt. In this case, it's a little bit more complicated than our previous prompts. You can search the web for information on a given topic, and you can record notes about that topic, etc. We give it an LLM so that it knows how to do stuff, and we give it 2 tools, one to search the web and one to record the notes of the research that it has made. A hint that you can give your agents is what other agents in the system they can hand off to. You just refer to them in an array by name. This is optional. The LLM will try and figure it out by itself, but it can make things a little bit more smooth if you give it hints about which agents it might want to hand off to. So the write agent is very similar. It can hand off to the review agent or the research agent, and then there's the function, the review agent, which can hand off to the write agent. Let's execute that box. And now we can run the workflow. So this is an agent workflow in a multi-agent mode. The way that we instantiate agent workflows for multi-agents is we pass in an array of agents. So here are the ones we just created, and we give it a root agent. This is the agent that it starts with. So in this case, the research agent, and we give it an initial state. As we mentioned, tools and agents can access this state all the time. So we want to tell it what the situation is when it starts. It has no research notes, the report is not written, and the review is not written. With that ready, we can now run it. So our user message is going to be, write me a report on the history of the web, describe the history of the World Wide Web. And what we're going to do here is just add a little bit more color by streaming the events back from the handler. So we're going to print out which agent is running, what output is happening, what tool results, what tool calls, that kind of stuff. This is the kind of user feedback that I was talking about earlier that's very helpful. So you can see our multi-agent system running. Whoops, which box did I forget to execute? Let's see. There we go. So it's running the research agent. It's planning to use the tool to search the web. It's calling the search web tool. Thank you, Dev The agent has now the research agent has now handed off to the write agent. The write agent is now running. It's written a report. It's decided to hand off to the review agent, and the review agent has written a review. So we can see the final output by accessing the state. Remember, we set the state with the report context. So let's access the context and print out the state. So we see the report is a history of the World Wide Web. We could also access the state to get the review and see what it thought of the review. Let's see if I can do that live. State's already done, so we just need to print state. What did we call it? I think we just called it review, right? Yes. Hate adding things live, but there we go. The report on the history of the web is well structured and covers the essential aspects of the topic, blah, 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 blah. Cool. Our multi-agent system has worked. The tools have worked together, the agents have worked together to solve the task that we gave them. Agent workflow is designed to be a simple jumping off point for putting together a team of agents. There is a whole lot of stuff that you can do using just agent workflow. But LlamaIndex is designed to do even more than that. So what are some situations where you might want to drop down from the multi-agent system and agent workflow to regular workflows, non-pre-built workflows that you build from scratch? One is fine-grained flow control. Workflows allow for looping and branching and parallel calls and map-reduce behavior. Workflows allow you to precisely specify how data gets passed around your system. And we're going to see that in a second. Another one is reflection. I mentioned this earlier. It's a powerful technique of agents is that you can use the LLM to judge the work that the LLM has done. So you can get the LLM to decide whether or not it did a good job and improve on it if it didn't. Other situations are structured inputs and outputs. Like I said, Agent workflow is relying on strings for input and output, but if you wanted to like throw JSON to it and get JSON back, you can build a workflow that works that way. Multimodality is another one. If you want to, it just handles text, but LlamaIndex is capable of handling images and audio and video as well. So you need to drop down to workflows to build those capabilities in. So let's use these features and create a new workflow from scratch. Here's the most basic workflow you can possibly create. Workflows are classes. They descend from the workflow class, and they, like I said earlier, they are defined as a series of steps connected by events. So the way that you define a step is you use the step decorator, and then you just create an ordinary Python function, and you tell it what event it accepts and what event it emits. In this case, we are accepting a start event and we are emitting a stop event. Those are both special events. Start event is always the first event to get emitted, and when a stop event is emitted, the workflow will halt. So we have defined our workflow, and now we're going to run this brand new my workflow exactly the same way that we ran agent workflow. It's exactly the same construct. It prints out hello world. As an aside, if you are running this on, we've been running all of this in a notebook. If your notebooks are async by default, if you want to run your workflows in Python, you need to enable async IO. So you would need to create an async function that has my workflow in it, and then you would need to import async IO and call async IO.run on that function. This code doesn't work in a notebook, but this is how you would run it if you were running Python on your desktop. Earlier, I showed you a visualization of workflows. That visualizer is built into LlamaIndex. So the way that you get it is you install the LlamaIndex utils workflow class, and then you call draw all possible flows. It will output an HTML file for you, and if you open that HTML file in your browser, you get an image like this. In this case, you can see our basic workflow has just one start event, one step, and then it stops. That's obviously not very useful, so let's talk about building multiple steps. As I said, steps are connected by events. So the way that you create a multi-step workflow is you create multiple events. So in this case, I'm creating some very simple events called first event and second event. And I'm creating a 3-step workflow called step one, called my workflow. In this case, step 1 accepts a start event just like it did before, but instead of emitting a stop event, it emits a first event. Step 2 accepts a first event and emits a second event. Step 3 accepts a second event and emits a stop event. So these 3 steps happen in a row. We'll run it, and you can see first step complete, second step complete, workflow complete. If you run it through the visualizer, you get something like this. So step 1, step 2, step 3. Still pretty simple. Let's talk about branches and loops. There's not much point to a workflow if it just runs in a straight line. You could do that in ordinary Python. A key feature of workflows is their enablement of branching and looping logic. And we think it's more simple than graph-based approaches you will see in other orchestration frameworks. So let's talk about how we do looping first. In this case, we're going to modify our workflow and add a loop event. And we're going to modify our step 1 so that instead of just accepting a start event, it also can accept a loop event. And it will emit either a first event or a loop event. And we're going to use a random number generator to decide whether a bad thing happened or a good thing happened. If a bad thing happened, it will emit a loop event. And if a good thing happened, it will emit the first event. So let's declare that and run it. Oops, I forgot to define loop event. There we go. So the good thing happened. That's the most boring possible execution of this. Thank you, random numbers. Let's run it again. And again, there we go. In this case, a bad thing happened twice. So it looped twice, and then a good thing happened, and it completed the workflow. This is what that visualization looks like. You can see step one now has this loop event, which can drive you back to step one, or it can complete the workflow. You can also do branches. In this case, we're going to create a branch with 2 steps and a second branch with 2 steps, and we will declare our steps to handle that. So a random number again will decide whether we go to branch A or branch B. Branch A goes from A1 to A2. Branch A1 emits a branch A2 event, which is handled by step A2. Step B1 emits a branch B2 event, which is handled by step B2. We execute that. This is what this visualizes as. You can see, you can begin to see the power of workflows now, that you're able to create multiple branches and loops for complicated events. I see a question from Sumya, who I'm going to handle that one at the end. The next thing you want to be able to do with workflows is concurrent execution. So instead of just a branch or a loop, you split off into multiple directions at the same time. This is useful if you want to do, if you have multiple long-running tasks, or if you want to perform something like MapReduce, where you take a simple task and a complex task and break it up into lots of simple tasks and then collect the results. So let's look at how that's done here. In this case, we're going to use a new method called sendEvent. So instead of returning an event, we're going to call context and say sendEvent. And we're going to send 3 different step 2 events: query 1, query 2, query 3. Step 2 runs a slow query, which can take between 1 and 5 seconds, and then calls a stop event. Remember, when a stop event is called, the workflow halts. So the first of these to win, the first of these to the first step 2 to complete, will call stop event and halt the workflow. So let's define that workflow and now run it. And we see in this case, query 2 is the one that completed first. So you can see if you were working with multiple LLMs, for instance, and you didn't know which LLM was going to get the answer first, you could query them all at the same time and pick the fastest one. But what if you want all 3 results? What if you wanted to get all 3 LLMs to answer a question, and then you wanted to sort of come up with an aggregate of their answers or a summary of their answers to get the best possible answer? Well, you can do that as well. So here our start event is the same. We emit these 3 events. We emit step 2 is the same. It takes a random amount of time, and then we call this new method the collect events method. We tell it what event to look at, and we tell it what to wait for. In this case, we're going to tell it to wait for 3 step 3 events. That's what that syntax does. The way collect events works is it will run every time this method runs, and this method will run every time a step 3 event is emitted, and it will collect the events that it receives. But if it hasn't received all of the events that it's expecting, it returns none. So what we do in this step is, if the result of collect events is none, then not all of the events have been received yet, and we return none. If it's not none, then we know that we've received all of the events that we want. So let's define that event and run it. See, it runs all 3 queries. And then you can see it runs twice without receiving the events. So as the events come in, it says not all events received yet, not all events received yet, and then it prints out the results of query 1, query 2, and query 3. If you wanted to implement MapReduce, you might not necessarily know how many of the events that you're going to have. In that case, you could use the context. So up here, you could set in your context how many events you've fired off. And here, you could say, wait for the number of events that we saw in the context. You don't just have to wait for a certain number of the same kind of event, though. You can wait for multiple events of different kinds. In this case, we're going to emit 3 events: a step A event, a step B event, and a step C event, each of which will trigger their own step. And we're going to tell our step 3 to wait for all 3 of those types of events. And then we're going to tell collect events to wait for those events, step C, step A, and step B. Note the order in which we're specifying this, because that's going to become important. So let's execute this workflow, and now let's run this workflow. So it did something A, something B, something C. It received all 3 events, and then it printed out which events it received. And you'll note that inside the result, the events that we received are in the same order as we told collect events to wait for them. So that's how you know which event is which. You get them back in the same order that you defined them. That workflow that I just showed you has this rather fun visualization. You can see it splitting up into step A, step B, step C, each of those steps, each of them committing an event and getting collected into step 3. Just as we did with AgentWorkflow, we can emit events back to the stream so that we can give a user a sense of what's going on in this workflow. Here you can see us doing that in this workflow. Yes, is the answer to Sumina's question. Can this branching logic be visualized using LlamaIndex utils, including the conditions? Yes, you can see how the splits happen. Let's look at this streaming. Step 1 is going to write an event to stream that is a progress event saying step 1 is happening. Step 2 is going to use our LLM for something. It's been a while since we've used our LLM for something. And we're going to call astream complete with the prompt, give me the first 50 words of Moby Dick. Astream complete returns a generator. That is to say, it streams the output of the LLM back to you. So we're going to pass a stream to a stream. For every chunk that we get from our generator, we're going to write a text event with a little delta, which is the delta that we get from the LLM. And then once it's complete, we're going to say second step is complete and return the full response. Step 3, we'll say that step 3 is running and halt the workflow. So define that workflow. And now when we run that workflow, we're going to be looking for those progress events and those text events that we got. Step 1 happened, and then it output all of the first 50 words of Moby Dick, followed by step 3 happening. And the final result was that the workflow was complete. So you can use this to give feedback to your user about whatever workflow you've put together. So we talked about agent workflows, and we've created a single agent workflow here. Now let us use a workflow to create a multi-agent system, just like the original agent workflow was. We're going to give it the same task, writing a report, but it's going to look a little bit different. So we're going to have a search web tool. We're going to use exactly the same one that we used before. I'm not even going to redefine it. And we're going to create 3 function calling agents. These, we're going to use the from tools method. So we give it the search web tool, we give it an LLM, and we give it a system prompt. And we have a research agent, a write agent, and a review agent, just like before. In this case, the write agent and the review agent don't have tools, and we'll see why that is. Let's define those tools. And now let's define our workflow. We have a research event, a write event, a review event, and a review results event. So we have a setup event, which will get called at the start, which will which will bring in the agents that we passed in. And then we will call research, which will set the prompt and tell our research agent to do some research according to that prompt. We pass it in here. It'll emit the write event. The write event will act on the research and then trigger a review event containing the report that it just wrote. which will then get reviewed by the review agent. So the reason that we didn't need tools is because the tools we used last time were writing stuff to the context, and in this case, we've hard coded in that these what is getting passed from agent to agent. So we've defined that, and now we can run it. We can give it a prompt, the history of San Francisco, and we pass in our 3 agents, and we're going to wait for a review results event emitted here, and then print out the final result. So you might wonder where this text is coming from, running step setup, running step research. I turned on verbose equals true in this case. And that's what that does, is it will just automatically output which step it's running in the workflow. The research is taking a little while. It's calling step right. Come on, LLM, you can do it. It's running step review. And there we go. So again, the LLM thinks this is a pretty good report. And here's the report itself, a report on the history of San Francisco. So earlier I mentioned one of the things that you can do when you're building a workflow from scratch is you can add reflection. So far, we haven't done that. We've been getting the LLM to write a review of the report, but we haven't been getting it to act on that review. So we can change that here. So we're going to introduce a new event to our workflow called the rewrite event. And we're going to make a couple of changes to this workflow. The setup is the same, but the research step is different. It's going to do the prompt the same way, but it's going to store the research for future use in case it needs to run multiple times. The write event is going to change as well. The writing is going to be based on the research that it found in the context. And also, if it has been told to do a rewrite, it will add to the prompt the fact that that it is doing a rewrite and that it should use the review to inform its rewrite. Finally, in the review stage, we're going to look at the review using an LLM. We're going to get the LLM to read the review and decide whether or not the review is good. If the review is good, it will output the word continue. If the review is bad, it will output the word retry. And depending on those, we will emit either a rewrite event or a stop event. So let's do that and execute it. So you can see it running the research step. Running the write step. Will it think this report is good or bad? We'll find out in 1 second, or possibly 5 seconds. It's doing the review event. And the reviewer thought it was good. So instead of looping back, it produced the result. But if the initial attempt by the LLM had been bad, it would have looped back and given it the content of the review and done it again. You can see this visualizer here. This is how that flow works. It runs through to the write event. The write can send a review event. The review can send a rewrite event, which loops back to write. And it can do that as many times until it decides that it's good. And that is the end of today's workshop. You have worked through from building a single agent using AgentWorkflow to building a multi-agent system using AgentWorkflow. And then we dropped down 2 workflows and created the whole thing again from scratch using the basic constructs. I'm just going to share my other screen again to show you some resources. So if you'd like to continue with LlamaIndex, a really great thing to do is to get involved in our Discord. You can find that link here. It's also in that QR code. You can also find the slides and this notebook linked at this QR code or this bit.ly address. I hope that this has been a useful introduction to LlamaIndex and all that it can do, and also to the wider world of AI-powered agents. It's been a pleasure to speak to you, and thank you all for your time and attention.